Today, we're talking about the two most important skills for AI engineers, design and planning. Most content online is focused on the wrong things, optimizing your Claude code setup, the latest agent harness tips and tricks, or even choosing the best model, but none of that will really help you build better software. So in this video, I'm going to show you how to think about design and planning as an agentic engineer. We're going to design and build a feature together. I've been building software professionally for the last 20 years, and all of the ideas and techniques I'm going to show you today are the same ones that the best engineering teams in the world have been using for decades. If you stick around to the end, I'll give away the 4 skills that I use every single day on my personal and professional projects. So let's get into it. So an obvious question is, why do I think design and planning matter so much when it comes to agentic development? So if you think about software development, there are 5 phases. The design phase is where we think about what are we building, why are we building it, and then how are we going to build it? So this is about understanding the problem and making decisions or choices about how to solve that problem. Then we break our work down into a number of tasks. We give those tasks to agents to write the code. We do some kind of verification step, and then finally we deploy to production. But if you think about these last 3 phases, largely agents can do most of them or the entire thing. So pretty much you should be able to give a task to an agent and have it open a change request for you to review. Humans aren't writing the code anymore if we're honest about it. And so really there's very little to do in the build process. If you're still manually prompting or you're doing things differently every time you have a piece of work, that's not going to scale very well. So typically you want to get to a point where you can give an agent a well-defined task and be confident that you've built your process in such a way that the agent will then open a pull request that is just ready to go pretty much. Verification will depend on what you're doing. A controversial thing to say here is it really depends on what you're doing. I've worked on mission critical systems with millions of users. You're obviously going to do a lot more human review, human testing in those situations. But equally, I work on side projects where I'm quite happy for agents to do a lot of the code reviewing, a lot of the verification and testing, because this is really about building the verification systems, automated code review, automated browser testing, automated checking, automated everything basically at this stage. But if you're working on something like a design, you still want to have a human in the loop. You don't want to trust agents to evaluate a design, for example. And then deployment to production has been automated for a really long time. Humans don't really deploy software anymore. We merge our code changes in, and then the system will deploy that to production. So really the only things left for us to focus on as developers are design, where we decide what to build and how to build it. This is really on us because these decisions are really, really critical and important. Planning is about breaking the work down, and then verification. Again, depending on what you're doing, you still need to do some level of verification and checking of the quality to make sure everything is good. So I like to think about design as 2 phases. The requirements phase is where we think about what are we building, why, and then for who. Then the technical design is the stuff we all think about when it comes to design. It's about making the choices around the stack, the database, the architecture, thinking about edge cases, security, operations, metrics, monitoring, alerting. How are you going to support this feature in production? All of those things are part of the technical design process. You can definitely use an agent to help you a lot here, and that's what we're going to be doing throughout the process. But really, if you work in a large company, you'll find that the most senior engineers in that company spend most of their time focused on technical design because it's the highest leverage and the most important part of the process to really get right. So we're going to look at 4 skills in this video. The design skill is going to allow us to build a technical design doc that we're then going to use to break down into tasks. We're going to use the architecture review skill to find edge cases, flaws, mistakes in the original design, and basically improve the original design. Then I'm going to show you the HTML doc skill, which will allow you to visualize your designs much more elegantly. It's very difficult to read markdown documents sometimes as humans. And then finally, the planning skill will allow you to break your design down into tasks automatically. One technique I really like to use right now when I'm building any project is to have an architecture.md file. The architecture.md file is an overall high-level architecture for the entire system. So if you imagine you're building a project from scratch, like a new web application or any new project, having this architecture.md file is a really great reference both for you and also for agents working on your project. So again, this is the same design doc skill that we're using elsewhere in the video, but this is focused on the high-level system design. It's the highest level. Here's the moving pieces, the database choice. So this is talking about the architecture where we have a server using React. We have a worker that dispatches to these, different coding agents. So these documents can be really detailed. So you can see here, this is the API definition. So we have a health check endpoint. We have a separate API for our worker. you can kind of just see there's just a ton of detail. We also have limits detail as well. These are the little things that get missed most of the time when developers build software. They forget about, what are the edge cases? What are the limitations? What are the controls? What are the rate limits? All of these little things will protect your application and make it really, really high quality. If, for example, you're building a SaaS application and you forget to add limits, a customer could, generate 1,000 resources and cost you a load of money. So these kind of things are actually really, really critical when it comes to building software. Thinking about limits, thinking about, edge cases, rate limiting, all of these kind of protections will really help you when you build out any real software. So for this video, we're going to pick a random application I happen to be working on that we can build a feature in. So let's run the server. So we're going to type just serve. And now we're going to start the application and then go into the browser and take a look at what this looks like. So for this demo, we're going to be building a feature in an existing application I've got here called Slate. This is just a project I happen to be working on at the time. The idea here is it allows you to manage your tasks and assign those tasks to agents. Pretty standard stuff. It looks pretty similar to many apps you're probably familiar with. We have an idea of a board and we have tasks on the board. We can create lists of things we're focused on. We have like a Kanban view. We have a table view, and then we obviously have a calendar view as well. So the idea here is that we can add tasks to our queue that we want to work on. Let's say I want to write an email draft response to, Tim. And then we want to have the agent basically pick up that task and do it for us. So in order for us to do that, we need to connect our agents. So you can define an agent over here. But in order for us to assign work to the agents need to be listening and watching these tasks. So that's the feature we're going to be building today. So the first thing we want to do is think about the feature we want to build. So the idea here is that we want to build a feature that allows an agent to listen, monitor the task board, and then basically automatically pick up the work. So what I'm going to do is use the design skill that I have written, and I'll link all of this in the description. We're going to say something like, I want to build a feature that allows me to adapt the CLI tool that we have so that it listens and watches the board for tasks to pick up. A task is suitable for an agent if it matches the agent's name and it's in a ready state. Any tasks that match those criteria, we want the CLI to automatically pick up and then delegate to an agent to implement the task. And then we want the agent to update the task board once it's finished, comment back on the ticket, and move it into a review state. So before we use the design skill, I'm just going to basically brainstorm first. So help me ideate this feature. So before we even move into writing this down into a document, I think it's helpful to get clear about what it is we're building. While I think you can get away with using a cheaper model for the implementation, the design is such an important part of the process. You need the agent to really think about all of the different conditions, the edge cases. So typically I will use the higher reasoning settings or the best model available to do the initial design, whether that's, Claude or whether that's GPT. So this is an example of where the agent's opinion and my opinion maybe differ on the implementation details, and you want to go in a different direction. So you don't want to always accept the agent's opinion. You maybe want to challenge it a little bit. So in this example, we're deterministically updating the state of the ticket after we've updated it, which seems pretty reasonable. But what I found is that this actually adds a lot of complexity, and I would rather the agent do the update because agents are pretty capable today. So I'm going to make the change so that it's the agent that is responsible for updating the task using the CLI tool. So what you'll find is as you go through this process, the agent will make a decision and you might disagree with that decision or challenge it or think about something in a different way. And you want to constantly kind of go back and forth with the agent on these design decisions. Okay, so Codex is now finished doing the initial design. And what we have here is like a clean executive summary, basically describing what this feature is, what the goal of what we're trying to do is in a really sort of simple and understandable way. Then we have some context about this system, and we have a diagram of how this is going to look. And we've got a proposal on the design. I like to spend a lot of time thinking about the user experience when it comes to these kind of things. So what does the user experience as they use this product? Like, what are the commands that they actually run? Do they make sense? Are they intuitive? Things like that, basically. You'll also notice we have a ton of detail in this document. Some of this is important because when you think about a task like this, there are kind of all these little edge cases and race conditions that might happen. An agent might claim a task, but then what if two agents are competing to claim the same task at the same time? So there's kind of these weird edge cases that you might not have even considered when you first started thinking about this particular feature. And really, the design phase is a chance for you to kind of surface these hidden like things you might not have been thinking about in the original design phase. So one of the things you might notice is how big and detailed this design doc is. And this is one of the reasons why I always break things down into smaller tasks, because this is just too much information, in my opinion, for an agent to handle generally in one shot. There's far too much going on here. There are so many different edge cases, test conditions, like implementation details we need to get right. So we're going to have a much better result if we can kind of break this down into smaller tasks. Okay, so now we have the initial design, but it's quite hard to read through that design initially. So what we're going to do is use the HTML doc skill. I'm going to say use the HTML doc skill to make this more readable. So this is the document that was generated by our skill. It's taken the initial design and turned it into a slightly more readable HTML version of that design doc, essentially. We have all of the same information, just maybe presented in a more readable format. We have a diagram which is easier to read. So we have this kind of slate watching CLI tool that is watching the API. We've got the database over here. So these diagrams are really, really important for understanding. If you're like me, maybe a visual learner, then having diagrams here can really, really help you understand what's actually going on. What might be interesting is to use a different model to critique this design. I typically would use the existing Codex model, but it might be interesting to spin up Claude and see if we can get Claude to review the design as well. So I'm going to ask Claude to review this. So review the at docs / let's find the actual document. Agent Task Watcher design MD file using the architecture review skill. All right, so we're going to ask Claude now to review this using the architecture review. You can see here we've loaded this architecture review skill, and we're going to see what Claude thinks about our design that was done in Codex. Like I said, I wouldn't always use a second model. I don't think it's necessary, but it can be quite interesting to see if you get a different result or different feedback. I think it's worth using the best models and spending more tokens on design, because this is going to save you money in the long run. If you make mistakes or you implement the wrong design, you're going to have to go back and correct those things. And it's much more expensive to correct mistakes, both in terms of token usage, but realistically in terms of, customer impact, development time. It's far better to spend a bit of time early on in the process getting this right than it is to kind of, take shortcuts at this stage. If you're going to spend tokens, spend your tokens on design. When it comes to reviewing a design, there are lots of things you need to think about, which is what makes design somewhat challenging in general, because there are all of these different edge cases that you probably haven't considered. Things like rate limits to protect, against the number of requests a customer can make in a given time period. You also want to think about, scalability. Does this design scale well? If I have 10 users, it might work great, which is the problem with vibe coding, right? You have something that looks great on a demo, but as soon as you put it into production, it completely falls over because it's not scalable. It wasn't designed very well. So what I'm going to do now is simply ask the agent to break this down into a number of tasks and then store them in an issue tracker. The reason I think you can largely just let agents do this because it's mostly mechanical. So I would definitely recommend using agents to do the task breakdown. Having worked in software for a long time, I can tell you for certain that humans are not very good at this kind of work, because it's incredibly complex, incredibly mechanically detailed. So for example, you can see that the agent is now, making sure that all of the invariants and the test conditions are captured within a task. This stuff is very time consuming for a human to do. I generally don't bother writing the tasks by hand anymore. I'll always use an agent to do the task breakdown. I just feel it leads to a higher quality result. The agents are just much better at keeping the detail. Okay, so what you can see is that we've now broken this down into 5 discrete tasks. So we're adding the run contract. All right, this seems reasonable. You can obviously review the tasks and make sure they make sense to you. Maybe there's something the agent has missed, but generally I will take the output of the agent. And you can see here we have a very clear summary of what the task is, the outcome that we want, and any kind of constraints, and what's in scope, what's out of scope, things like that. So I'm pretty happy with these tasks. They seem reasonable to me. So what I'm going to do now is just ask the agent to create the tasks for us, create these as GitHub issues. What I didn't do here is link them all to a parent ticket. So it can be quite confusing. If you have a large number of tasks or tickets in a task manager, it's very easy to get confused. So all of these tasks relate to the same unit of work. So I'm going to ask the agent to correct itself, link these tasks to one parent ticket. Okay, so you can now see that we have these 5 tasks. As I said before, the level of granularity in your tasks will depend on what you're doing. Some people might just want to vibe code the whole design, like just run through it in one shot. If it's a simple design, you can probably do that, capture it in one task. But if it's anything more complex where you need to kind of test and iterate as you go through the cycle, it's just helpful to break things down into smaller number of tasks. So we have one parent ticket here, which we can take a look at. This is what it looks like in the browser. We have this one task. So build the agent task watcher, which is what we've been planning out. And you can see here, we have linked all of these, sub issues that need to be done. And we also have the delivery order. So we have an acceptance criteria that all of the issues are complete. We have, a rollout plan to deploy this. So a pretty detailed ticket. And at this point, you can just hand this off to an agent and let the agent work through all of these tasks. So what I would typically do is just use Codex to build out the rest of the tasks, but there's nothing stopping you using a different agent if you wanted to. So I'm going to go ahead and just use Claude to build out these tasks because all of the tickets are really detailed. We have, the design document, all of the details in the ticket. There's really nothing else that the agent needs to know at this point. So let's go ahead and build these out. So I'm going to use the task to PR skill. And then I'm just going to pass in the parent ticket. And then that's pretty much it. I'm just going to wait now for the agent to work through these tasks, sequence them. This skill is going to make sure that all of the changes are tested. They've got code review. And it's pretty much just a case of now waiting for the agent to burn through these. Thanks for watching the video. I hope you found it useful and valuable. If you did, please remember to like and subscribe because it massively helps out this small channel. And I'll link all of the resources for free in the description below. I'll link the skills that we talked about as well. So you can download those, use them in any way you want. You're free to adapt them. Whatever you want to do with them, it's totally fine. Thanks again for watching, and I will see you in the next one. Take care.